Hi everyone, we're going to sketch the curve and find the area that it encloses. We have a cardioid. These numbers are our A's are both 1, and I'm assuming, which I shouldn't, but I'm assuming that if you're doing the area, which means integration, that by now you are familiar with the polar curves. So let's plot some point. We only have to sketch it, so it doesn't have to be perfect. So at negative pi divided by 2, we're at 2. I'm going to go by 2's. So it's going to be 1, and this will be 2. At 0, we're at 1, which is here. And let's get closer in. At pi divided by 6, we're at 1/2. At pi divided by 3, we're at really close to 0. And at pi divided by 2, we're at 0. Then you work yourself back around. It's symmetric to the line theta equals pi divided by 2. And so for pi divided by 6, let's see, we're getting close in here. So it's swinging out like this, a little bit like that. Then we're at 1 here. And then you can kind of just graph it from there. At 11 pi, at negative pi over 6, we're at 1 1/2. So let's see, 1 1/2. All right. So that would be the same as pi over 6. So we can just make a cardioid like this. Just have to sketch it. So basically the idea of this is to find the area enclosed, which means this area. Now to graph this, we had to use everything from 0 all the way around to 2 pi. So that's going to be our integration part. So our A is going to equal 0 and our B is going to equal 2 pi. And we can integrate it as the area equals the integral from 0 to 2 pi of 1/2 of my r squared d theta. My r is 1 minus sine of theta. All right, so let's simplify all this. I'm going to pull out the 1/2 from 0 to 2 pi. Expand this. This is 1 minus 2 sine of theta plus sine squared of theta d theta. Excuse me. Now, I'm going to use my identity for this and write this as 1/2 the integral of 0 to 2 pi of 1 minus 2 sine of theta. And then for this piece, I'm going to write this as plus 1/2 times 1 minus cosine of 2 theta, d theta. All right. Now, the next step I'm going to do, because I'm moving to the next slide, so I'm going to multiply these two and add to this 1. So that's going to give you 3/2. So what we're going to end up getting is, let's see, 1/2 times the integral of 0 to 2 pi, and now we have our 3/2 minus 2 sine of theta. And then when you distribute it, that 1/2, you're going to have 1/2 cosine of 2 theta, d theta. All right, let's go ahead and integrate this. So we still have our 1/2. This is going to equal 3 divided by 2 theta, plus this piece is going to be 2 cosine of theta. Have to change your sign. And then this is going to be 1/4. So you're going to multiply this by 1/2 sine of 2 theta. And we're evaluating this from 0 to 2 pi. This is going to give you 1/2. Now, this piece here, when you substitute this in, is going to give you 3 pi plus cosine of 2 pi is 1. So that's just going to be plus 2. It's just going to be 1. All right. Minus, now substitute in your 0. This is going to be 0, and this is going to be 2. So we have 2, and this is going to be 0. So this is what we have, and this is going to simplify to 3 pi. Well, first of all, these are just going to cancel. 2 minus 2. So we're just going to have 3 pi divided by 2 is going to be your area. Thank you. Have a nice day. Bye-bye.